Good afternoon, my fabulous chemistry students. Video 11. One more after this, and we are done. Measuring matter. We will be able to compare and contrast mass and weight. They are different. We need to get two methods to measure volume. This middle one, classic example. This one, the one you might not know, volume displacement. Measure mass and volume, calculate an object's density. We'll use mass volume to do calculations to help us in lab. How do we measure matter? There are many ways to measure matter. We can use a ruler to measure dimensions in order to calculate volume. Sometimes we have to use what we call displacement to do irregular objects as far as volume goes. So measuring matter onto our notes, starting with mass versus weight. Mass is how much matter something has. Weight depends on gravity, the force pulling an object towards the Earth, moon, or other planet. What do they have in common? Directly proportional. As mass increases, weight increases. So here's one of the things I would always say to you guys to keep this straight. Mass is how much matter I have. If I go to the moon, does the number of particles and molecules that I'm made up of change? No. That's mass. But if I go to the moon where there's less gravity, does my weight change? Yes, it's going to be much less because the gravity pulling me down on the moon is less than the gravity pulling me down here. So we really only work with mass in chemistry class. If you hear me say weight, you can correct me, I promise. And I will say, yep, you're right. We have the same mass whether we are on the Earth or the moon, right? The different forces of gravity cause the difference in weight. So that's that. Now, volume. Something's volume is how much space an object takes up. Okay, liquids, we use graduated cylinders. Okay, regular solids, we can use dimensions with a ruler, calculate its length, its width, and its height, and multiply. But for irregular solids, where I can't really measure their sides very well, we do what's called the displacement method. So, displacement method. Let me go into this just a little bit farther. Ready? I have my graduated cylinder. You saw it on the front thing. And then I have another graduated cylinder. And after I put this irregular object on it, you see how the volume rises? Well, this difference in volume right here is going to be the volume of this piece. All right, so this is what we call volume displacement, the amount of volume that the piece displaces. So we're going to have to do that in lab. Then density. We're going to have to do density in lab. The amount of mass in a given space. The ratio of mass to volume. I hope you guys know this formula already. We'll write it down. It is in table T in your reference tables when we get those. Density equals mass divided by volume. So, looking at box A and B, which box has a higher density? Explain. I say it's box A. In class, I want to see your explanation. Okay? Density problems. You must show all your work. Density of water is 1 gram per milliliter or 1 gram per cubic centimeter because a cubic centimeter is a milliliter. Now this is known. Displacement versus length times width times height. What is the density of an object that has 60 grams and a volume of 2 cubic centimeters? Well, I know that density equals mass divided by volume. So density, I'm going to plug and chug, we call this. I'm going to plug in my mass, 60 grams, divided by my volume of 2 centimeters cubed. 60 divided by 2 is 30. My density now is, oh, this is the chug part through the calculator. Oh, I wrote a 6. Density is 30 grams per centimeter cubed. Number 2, if you have a gold brick that is 2 by 3 by 4 centimeters and it has a mass of 48 kilograms, what is its density? Density equals mass divided by volume. In this case, I don't know the volume. I have to calculate it. So it's length times width times height. So it's 2 times 3 times 4, which is going to be 2 times 3 is 6. 6 times 4 is 24 centimeters cubed is my volume. And I'm given my mass, so I can plug and chug now. Density equals 48 grams divided by 24 centimeters cubed. Density equals 28 divided by 24, 2 grams per centimeter cubed. Okay. 3. All right, I have the density. So I'm going to start this one for you because it's plug and chug again. I have density equals mass divided by volume, but in this case I'm given the density. So I'm going to plug that in to the D. So 0.6 grams per centimeter cubed is now going to equal 120 grams divided by some volume V. I want to see who can solve this and see how good you are at your algebra. I also want you to do 4 and 5, okay? And we will check them in class. You should now be able to understand the difference between weight and mass. You should understand how we measure volume in both different ways, length times width times height or displacement. Use them to calculate an object's density, and use the object's density to find its mass or volume depending on the missing variables. This is what we call plug and chug. Remember, all of the equations are going to be the same. D equals m divided by v. It's up to you to figure out which ones we're going to plug in based on the givens. All right, guys, that's our second to last video. Have a good night.